So hello and welcome to the Modern Software Engineering channel. Dave and I today are going to be talking about how we stop our AI agents running rogue and how we can protect ourselves from all the awesome things they can do. Hello, Dave.
It sounds like a fascinating topic to me and a scary one.
Yes.
But before we get going, this episode's sponsored by Docker, so I'd like to thank them for their sponsorship. So if you're using coding agents in your workflow, you've probably noticed the tension. You either give the agent full autonomy and it might touch things that you didn't intend, or you lock it down with approval prompts and lose the speed that made agents worth using in the first place. Docker Sandboxes are purpose-built to fix that problem. Each agent runs inside its own microVM, a real development environment with full package access, network controls, and proper hardware level isolation from your host. Nothing persists, nothing leaks, and if something goes wrong, you just spin up a fresh environment. It works with Claude, Gemini CLI, Codex, and more. So do take a look at their links in the description. Thanks. So on to our topic. How do we safely contain AI agents? So, Sam, how do we safely contain AI agents?
It's a tricky thing, right? Because they're becoming more powerful. We can have them do more things, but there's always this degree of we're not entirely sure exactly what they're going to do. I mean, now by definition, non-deterministic, and complex workflows mean they could be doing things, and they're often trying to be very helpful. They'll often go above and beyond what you've asked them to do in an attempt to be helpful, which can often end up being pretty disastrous. So, I think kind of like winding it back, there's a really great article by Summer Willison from about a year and a half ago. And he talked about this concept called the lethal trifecta. And he said that if you give your agents access to your private data, exposure to untrusted content, so this could be a prompt given from an outside person, for example, or basically a prompt that you yourself have not vetted, and the ability to communicate, you're in this kind of dangerous space. Because if you think about those three things together, if I only had two of them, I might be all right. Like, so say someone gets a prompt into my system to steal your private data. Great if I'd access the private data, but now I can't get it out. So actually that lethal trifecta gives us a good way of thinking about these elements. So if we're trying to restrict what an agent can do, anytime an agent has access to private data, untrusted content, and the ability to exfiltrate, immediately alarm bells should start ringing and you're thinking, I've got to be really careful here. And so that's kind of the groundwork we're laying with, really, is like, and this fundamentally is kind of traditional principal privilege stuff. But
so kind of a good model for the principled approach to when to be scared.
Yes. I'm going to give one example of how these things can be helpful to give you an idea of a quite an innocent example of an agent doing things that you didn't want it to do. So a client of mine was using Claude to access basically some production data. And the way they were doing it first was they were building a set of skills and guardrails around it. And they were testing it on getting some information from staging first. And they very explicitly gave Claude a token which only allowed it to access staging and only allowed it to access a specific client account in staging. And what they were trying to do was to say, is there a way we can use Claude safely? And so they did a kind of a sensible thing, which they set up all these agent skills and everything else. And then they said, okay, I'm going to ask you to access client A. Oh, you can, great. Now I'm going to ask you to access client B, which I know you shouldn't be able to do. And he was trying to make sure it's definitely not doing anything it shouldn't be. And it did. It managed to access client B. The way it did that was Claude went, oh, I can't access that client. And so it went looking around on the rest of his computer, found a completely separate credential in the browser, used that to access, rather than staging, production, and then pull down the data. Now, luckily, it couldn't do anything bad with that data, but that's an example of where you try and apply kind of quite soft guardrails around it. And that was an example of a non-malicious kind of issue occurring. And so that's sort of on the coding agent side. And we've heard examples of Pocket OS, which I did a video on for the channel, where this kind of problem resulted in production database being deleted. But then, of course, this gets even potentially worse when we consider that we're now putting agentic workflows into our production software.
Yes.
And prospect for these things being exposed to outside influence through untrusted content and untrusted prompts.
So not just with our data, but with our customers and users' data as well.
Yeah. And with more scope. I mean, you think about the good old-fashioned SQL injection attacks and things like that.
Yeah.
Well, if you can find a way to inject a prompt in, that's potentially even more dangerous into a production system. So there's a whole bunch of kind of bigger concerns, that are around this.
I think the other thing that seems interesting to me, I'm probably like most people. I find AI interesting on a number of levels intellectually. One of which is this philosophy of us inventing aliens that are able to, at some level, reason roughly on a par with us, at least. And that seems like a very weird thing. But one of the big problems in AI at that kind of philosophical level is what's called the problem of alignment, which I think what you've just said touches on. So these things don't have to be the Terminator and evil in order to do things that we think of as wrong. And that's a big problem. So if we are asking Claude to access this account, but not this other, that can be for very good reasons. And then if we ask it to access the other to test our guardrails, and it does, that's it doing what we've asked it to do at some level. So how do we get it to align with those deeper things is a seriously big and complicated problem, which we're probably not going to be able to solve with the kind of guardrails that we're talking about. So we're probably more talking about rules of thumb of how to be safer rather than how to be completely safe.
Yeah, it's probably worth explaining just a little bit on that aspect, right? LLMs have no ability to reason like humans do. They can't understand causality. They can't understand consequence. And even like in the Pocket OS example, the agent was explicitly told never do anything that deletes production data. It was extremely explicit, and it did it anyway. And the guardrails are sticking plaster on a fundamental solution, which is never going to fundamentally be able, in the current form, to determine, if I do X, that means I've deleted production data. And if I delete production data, that means Y and Z. Now, there are aspects of AI, certain subsets of world models that could do that, but that's not what we're talking about.
Yeah.
And so we're in a situation where I don't think we can rely on the guardrails that either we put in or that other people put in. And so for me, it's more like, okay, if we treat these things as being malevolent sprites that occasionally are really useful, but occasionally are dangerous, it's like, let's stick them in a big old box and stop them from getting out, right? I mean, that's kind of the current thinking around a lot of this is, let's take our agents and basically sandbox them in such a way that if they do something we didn't want them to be able to do, we deny them fundamentally the access to do the bad thing. We deny them access to our private data or exfiltration or whatever else.
So in essence, containing an agent in that sense is just the same problem of running any untrusted code.
Yeah.
It's just that now the code that we're running is non-deterministic and has some level of initiative to, some goal-seeking ability to try and find its way around barriers, which makes it a harder problem.
Yeah, absolutely. And this is also what's sort of, and I think talking about it in terms of untrusted code, I think is absolutely spot on. And I think the difference is, as you say, when we write code, we can understand to an extent what it could end up doing. We can run tests and everything else and verify that our protection mechanisms are likely to protect us. It becomes a bit more difficult with agents. And that's also why a lot of the attention from a technical solution point has moved to things like to looking at things like microVMs rather than, say, traditional container workloads isolation. There are still a bunch of things that can break out of a container. It's better than it used to be like 10 years ago, right? It was very easy to bust out of a container, certainly if you're running the whole thing as root. But nowadays, there's still other attacks. So this is where people using things like microVMs, which is what's used inside Lambda. So if you think about what Lambda is on AWS, which is the thing that spins up a workload on demand and shuts it down, that's untrusted code. Amazon are running that on a shared platform with a bunch of other people's Lambda functions. So they need a way of making sure that your untrusted code can't bust out and do things it shouldn't be able to do.
Yeah.
And so they're Firecracker VMs, which is basically a microVM solution. Is what they use for that. I mean, I think that's at a technical level is part of the solution, but we also then need to think about this sort of architecturally as well, because if you have one agent that does a load of different things, you then stick it inside a microVM, you still have to give that thing fairly broad permissions to be able to do its work.
Yes.
And so every new bit of access you give it increases the chance that you're going to give that agent the lethal trifecta. So yes, the microVMs can to an extent help, but we also need to, I think, get good at taking those a big agent and breaking it down into smaller pieces that we can isolate the individual pieces and isolate those things in different ways is probably where we need to go.
But it's still risky. I think it's important that you did point out that it's still risky. So fundamentally, we're using a microVM as a kind of sandbox, and philosophically, what we're doing is we're changing the dynamic. So rather than just letting it loose on our open environment, we are deciding to put into the environment that it needs to complete its task.
Yes.
So that's a bit of a limiting case in it's a limitation from the AI's perspective in terms of the blast radius that we're allowing it to play with. We are controlling that a little bit more. Hopefully that makes us be a little bit more thoughtful, but we've still got to be thoughtful about what we give it access to. So we are giving it permission to access those things within there. If they compromise the lethal trifecta, they enable the lethal trifecta, we're still screwed potentially.
Yeah, I mean, so if you think about coming back to that example of my client who had that issue with Claude, one of the ways you could have defeated that would be to say, I'm not going to give you, I'm going to run my agent in microVM, and you only have access to these files.
Yeah.
And you only have access, like a volume, and you only have access to this network endpoint, for example. And then that way, firstly, Claude wouldn't have been able to find the other credential on the machine.
Yeah.
And secondly, even if it did find that other credential, it wouldn't have been able to access anything than the defined endpoint. But that requires you to effectively go into a kind of a whitelisting model rather than a blacklisting model. So probably the way to, if any of you have ever used AWS, we spun up an EC2 instance, right? By default, those things can't see anything. You have to explicitly go in and say, now this port's open. Now, of course, some people go and say, I'll give you access to everything, in which case, well, I can't help you. But I think that's kind of the model we're getting to, is like, you can't do anything, and I'm going to enable the things you're now allowed to do.
And hopefully the point at which you realize that, it needs access to this, is the point at which you stop and think, but that's risky, and that's an enabling step, allowing it to do something bad. The problem with that, it seems to me, practically, is the problem of kind of coding with Claude or one of the other AI assistants, is that you either turn it on and let it run and behave like an agent, which is what they're kind of designed to do. We give them a task and they go and run and complete the task for us. That's what we'd like to happen, but we'd like that to happen safely.
Yeah.
And the other extreme is that it says, am I allowed to touch this file? Yes. Am I allowed to touch this file? And after a little while, unless you're very diligent indeed, you stop really paying attention and you're just hitting yes all of the time.
I mean, there is very much this, that if we talk about specifically the coding agent or the software development helper, there's absolutely this tension, right? Because to make them useful, they need access to things.
Yes.
Like if you want them to be able to manipulate your code, they need to be able to see the volumes where your code lives. If you want them to be able to pull back observability data to help you sift through things in the wake of an incident, they need access to your production telemetry, right? And so you start adding these accesses on because it is useful to do so, and so you want, thinking about things like Claude Cowork, or if you're using, heaven forbid, using something like OpenClaw, right? You're giving it access to your bank accounts. And at some point, I think bank accounts know a bit of my local file system, yes, and everything in between is like crazy, right?
Yeah.
And I think that's a really tricky thing. And I think we also have to be aware that the AI vendors, I would say certainly it's not currently something they seem to care about making that easy for us.
Yes.
Right. For all the things that Claude and Codex can do that are useful, they don't seem to be making it easy for us to make using those tools safe and secure because they've got other drivers.
Yes.
So I think we have to be aware that in that environment, we're a little bit on our own. And I think this is an even corporate environment. This is where getting support about how to do those things well is useful. And this is why, you've got people trying to make microVMs a bit easier to run, for example. When it comes to our production software, of course, it's all on us at that point. And we can and we should be much more careful, because I think we should be careful either way, but the tensions are a bit different. And also we have the ability to kind of subdivide and think more about agentic workflows. And to an extent, the agentic workflow stuff does help, right? Because if I have lots of little jobs that are happening, I can give each of those individual jobs much more limited access. Then the problem becomes back to what's controlling your harness or orchestrating your workflow, of course, in those senses. But that at least can help. So to give you a simple example, rather than having an agent that can access all my production data and can email and exfiltrate, I could have an agent that accesses the production data but can't do anything else.
Yeah.
It does some processing or whatever on that information. It then sends back a small payload based on that private data to another agent that maybe can email, but now can only email using that very small amount of private data it was given. It's much more easy to restrict it. So you start thinking about it. We almost have, like, I think we think, if we think architecturally about that, we can do some interesting things in our production software. I think at the moment on our sort of on development machine, activity, I think that I'm less certain as to how we do this stuff safely.
Yeah.
And I think it's disappointing to see very little help or support coming from the big sort of coding tool vendors in this space.
So I think on the first part of that, before we get to your worry, that's kind of counterpointing two different approaches to thinking about the agent. One is a kind of as a component that we architect around. So we limit the scope of the agent's task and its inputs so that it can do little harm. It is one way of exerting control. And the other is to treat it as this more amorphous thing, and that's a threat that we need to monitor in order to be able to determine whether it's doing anything that we don't like.
Yeah.
And that's a different. We probably need bits of both of those, and particularly in the scenario, the second one, in the scenario where we are running agents as part of our system and dealing with data that's beyond our direct control because it's user data. Because the surface interface to an agent is natural language on the whole.
Yeah. I mean, I've not met any security professional that would think the second approach is something that they would countenance, right? I think it's too difficult a problem to deal with at the moment. And so I think if you really want to sort of think architecturally from a security standpoint, I think the former approach is where you need to be in terms of, because it's putting any AI stuff to the side. Firstly, we're using some fundamental security principles that I think are well understood, like principle of least privilege, defense in depth, right?
Yeah.
These are things that just we know as core concepts work, and they make it easier for us to reason about the systems, right? That box is a limited number of inputs, limited number of outputs is much easier, right? So whether or not we ever get to kind of the extreme end of the other model, I don't know. I actually also think we've got another set of forces maybe acting upon us, which might make that second model less attractive anyway, which is because of increasing costs, pay by usage concerns. We're now wanting to have sort of more, if you think about the more specialist skills that we want to run, to limit context windows, to limit token use, and actually have a bit more cost control. That I think also pushes us much more naturally to, rather than the one big thing that could do lots of different things that I've got to keep an eye on, I think actually pushes us much more towards small components where I'm using AI in some places, but I've got more control over cost control. And even in certain situations, maybe the ability to say, we now understand this problem well enough that we can replace it with a, hand-rolled raw code deterministic solution, right? So I think in the short term, the former model is probably where we need to be. And you'd certainly in an enterprise or corporate context get less pushback from an internal security team about that model as well, because I think it'd be understandable to them.
So I think one corollary of that is that the foundation models that we're all using are completely untrustworthy because they are working on the guardrail model, not the constrained least privileged model. So we have to apply that to them. But that means that on their own, as you've alluded to, but saying it directly, they are untrustworthy, and we should treat them like that.
Yes, I think where it gets interesting is it's like what they're exposed to, coming back to that lethal trifecta model. So let's assume that the, Anthropic and OpenAI people have done the best job they possibly could to make the thing good.
Yeah.
Fundamentally, they're still exposed to untrusted content.
Yeah.
Now, from a software development point of view, that's kind of our code, right? That's part of it. But that's not the only thing that they're exposed to. So there are already examples of people basically doing supply chain attacks to inject stuff into things like Claude and Anthropic. So
yeah,
I would sort of say kind of, they're not, I wouldn't say that the software itself is untrustworthy. I would say more that by their nature, they're making it easy and almost requiring untrusted content.
So by saying it's untrustworthy, I don't mean that it's malicious from those vendors. I don't mean that they are being sneaky themselves. What I'm saying is that by its very nature, I'm putting words into your mouth, so correct me if they're the wrong words. But it seems to me that the consequence of what you've said is that no security professional that you've ever met would apply that second level of thinking in terms of, is it enough just to monitor?
Yeah.
Then what we're saying is that if we've got these generalized agents, that's a huge risk that they are not sufficiently controlled. And that's what the foundation models are. They are these generalized mechanisms on which we are meant to be using for other things. But as they come out of the box, because they're already out of the box, then they are risky things in terms of their capability for the reasons that we've talked about, that, the variance, the goal seeking, all of those things. They are inherently risky things to use. And so we ought to be very careful. I also wanted to come back to the stuff that you were talking about in terms of the capability, some of the techniques, just to try and ground this. And I liked that you were talking in terms of least privilege. And I think that goes to other things, other ideas that you talk about a lot architecturally, like bulkheads, cell-based architecture, thinking in terms of blast radiuses and all that sort of thing. It seems to me to play very much to the idea of modular systems, but not just in terms of class or component design, but in terms of the way in which we structure the use of agents.
Yeah, absolutely. So I think if we think about any architecture, we're going to break apart into components or whatever you want to call these modules.
Yeah.
You can approach that through a number of different lenses, right? You can say, okay, I'm going to break this bit of code up and this bit of code up because this team wants to own that bit and this team wants to own that bit, right? So you're taking maybe an organizational element. You might take a technical element, a technical approach to it, because you think about the three-tiered architecture, that's a technical approach to decomposition. So there's always these different forces that sort of make us think differently about how we break code apart. And for me, like coming back to it from a security standpoint, if we're putting AI agents in the mix, that increases the prioritization for me of using my understanding of the security concerns as a way to drive those modular boundaries, right?
Yes.
Because there could be like 15 different criteria you could use to decide how do I break up a piece of code, right? You could go whatever it might be, coupling, whatever else. But I think that once you bring an agent into the mix, suddenly those concerns about security bubble up into maybe being one of the primary reasons that I'm going to draw a certain boundary a certain way. And that's something I'm exploring at the moment I'm doing work for another book at the moment in this topic. It's like, once you throw that mix in, does that change how we think about how we componentize our systems and how we modularize our systems?
So we are striving, again, I'm putting words in your mouth. So we're striving to move from the agent deciding not to delete production to the agent couldn't delete production. We've put enough walls, we've limited its access in a way so that it's not possible for it to do those things.
Yeah,
and so
absolutely.
That's really about why the compartmentalization matters.
And I think coming back to the point you raised earlier about that our coding agents are inherently kind of dangerous to an extent, right?
Yeah.
And I kind of mentioned earlier AWS, this idea that when you spin up a resource, there's a term secure by default. By default, you can't do anything with it.
Yeah.
Some of our audience, and I'm sure you know about a database called Mongo. Mongo was not secure by default. So Mongo, when you launched a Mongo instance, would run an admin interface to allow you to access its production data with default passwords and things on it.
Yeah.
And it was part of making it really easy to use as a developer, right? And it was help it, and to be fair, Mongo did quite well. It's obviously very, very successful. The problem with that was it wasn't secure by default. What did that mean? Lots and lots of people ran production Mongo instances with these backdoors available on the internet. You could actually just do a simple Google search and find the backdoors for all of these Mongo databases. And that's not saying that Mongo were trying to expose your production data. It's just that for them, that wasn't important. Secured by default was not important. The danger with that, from a product vendor point of view, is like, oh, we're just giving you this tool. It's up to you how you use it. But if people keep using the tool you gave them and keep stabbing themselves in the face with it, eventually they're going to start blaming the tool, right? So I think there is, thinking of the Anthropics and the OpenAIs and Microsofts of the world, right? There is a duty of care, I think, to them to see making it easy for us to operate safely should be a core part of what they offer. So maybe there's always inherently going to be some risk of coding agents because of some of the things we've explored.
Yeah.
But they should at least give us some functionality that allows us to implement these safeguards more easily. And maybe there is a line between checking every single file access and access to everything, right? I would just like to see this not have to be something that we in the community have to deal with. It'd be nice to see the vendors themselves.
And once again, it's one of those lessons that seemingly we are forced to learn over and over again. You could argue that Microsoft made the same mistake with Windows. By default, it was unsecured. Unix, on the other hand, by default, you had to, as part of the installation, you had to give it a root password.
Yeah, I think that's a great analogy. Yeah, it's a great comparison point. I think that's spot on. Yeah, and I think I also do have a sneaky suspicion that limiting what our agents can do through a security standpoint might align quite nicely potentially to trying to reduce their token use. But time will tell on that. I think when it starts becoming a cost issue, it goes from being a concern of your CISO and it becomes a concern of your CFO. When the CFO gets involved, people start paying attention.
So I think we're probably at wrap up time. So what do you see as the wrap up? What's the key?
I would say if you want, let's maybe split it. Let's talk about the coding agent and the production thing. I think for the coding agent thing, if you really want to sandbox your agents, look at microVMs and limit what you do. And actually doing the thing my client was trying to do, which is testing the limits of what your agent thinks it can do to see if when your own internal guardrails don't work. And I think in production, it's thinking about that lethal trifecta and trying to ensure that you never have an agent that has access to private data, the ability to take untrusted content, and the ability to exfiltrate. So I think as long as you can try and make sure that the components in your system, none of the agents have access to all three at the same time, that's a good starting point.
And as soon as you add the third one, think about how to limit that, how to control that access.
Absolutely.
In ways so that it's not going to go beyond what you imagine.
Absolutely.
That's so great. Thank you very much to everybody for watching. Thank you to Sam for his expertise and advice. A fascinating topic. Thanks and bye-bye.
Thank you.